Hi, I'm Joe Zamataro for PWC Muscle, and in this insider video, we're going to show you how we manufacture the P3Labs Spark Ramp Kits. These kits are good for any older model 2014 through 2016 Sea-Doo Spark, and will give them the same VTS range as the newer Trixx models. All you need is VTS installed on your IBR equipped ski. These kits are manufactured in-house right here in Tampa, Florida on our P3Labs Okuma CNC mill.
A CNC mill is kind of like a 3D printer in reverse. While a 3D printer uses additive manufacturing to build the product, a CNC takes a solid hunk of material and cuts it away. So each kit starts their life as a solid piece of specialized plastic. From here we start cutting away material like a sculptor producing a sculpture. The first step, however, is getting the design digitized and made into a 3D model. A lot of hours and testing has gone into making sure the correct geometry works for the brackets, with Jeff Brown doing a lot of the R&D. You can see the model accurately reflects the geometry on the ramp. Back to the CNC. The way we cut plastic is by using different specialized drill bits known as end mills. While a drill bit is designed to cut axially and make a hole, end mills are designed to cut from the side. This allows us to create tool paths to cut away the material. Some of the end mills are larger and used to cut away substantial amounts of material at a time. Some are smaller and much better at fine details. Some end mills have angles, like the one used on the side of the ramps, and yes, even standard drill bits are loaded up. So on the computer, we need to work within our computer-aided manufacturing software to develop tool paths for our CNC. Here you can see the individual paths that we developed within our CAM program. Each feature has its own set of paths and specific end mills. Once we have the tool path set to our liking, we can tell the software to generate the G-code. G-code is the language the CNC uses to move around and make the cuts. We load the G-code up on a second computer we have dedicated to the CNC. This makes small changes to the G-code much faster and easier, plus we can store a lot more programs at once. Here you can see them working in tandem as the computer feeds the CNC the G-code, then the CNC moves the end mill on a path specified by the G-code. Sometimes it takes a couple tries to get the G-code just right, and in the process a kit will be ruined or will break an end mill. We make adjustments and keep trying until we have a verified G-code that produces a kit properly. There's a lot of knowledge to acquire with machining, and we are constantly learning and improving along the way. Before you know it, the solid chunk of plastic starts to resemble our kits. Now each kit has two operations for cutting them, one on each side of the kit. Each blank will produce one pair of brackets. We run a full batch of about 20 on one side, and once all of the blanks have been machined on the first side, we'll start the second machining operation on the other. When the batches are all complete, they get boxed up, and it's usually just a short while before they fly off the shelves and into a rider's hands.
As you can see, there's a lot of steps to making one of these kits. From the research and development to the computer design, material selection, operating the CNC, even the packaging. To get your P3Labs extended bracket kits, visit us on pwcmuscle.com. We hope you've enjoyed watching this video as much as we've enjoyed making it. Part production is one of the more fun aspects of this industry, and we look forward to bringing you more products. Stay tuned for a fast-forward video of a full bracket kit being manufactured on the CNC. And until next time, ride fast, and we'll see you on the water. Check out our latest videos by subscribing, and be sure to hit the notification bell so you get an instant notification every time we upload new content. And in the meantime, here's some additional videos for your viewing pleasure. Sexy eyes, yeah.